What is the area of this blue shaded region? And don't worry, I'm going to give you enough information that we can definitely find the answer. But ultimately, I want to try to find the answer not with this blue shaded region, but with this pink shaded region instead. Let me show you how. Shaded region area questions, also sometimes called composite region area questions, are usually about what regions you can find the area of and then add those areas together. Sometimes shaded region area questions really should be approached this way. This is a quarter circle area problem I've done before, where if we can be clever about how the different pieces fit together, we can find the area by adding them up. And there is a way to do this particular problem, a shaded region area question I absolutely love, doing the whole addition thing. But it's not what I would consider the best approach to this particular problem. Let's get some specifics out of the way first. We do need a little bit more information for what's going on here. This is a quarter circle. You can see the right angle marker I've brought up now, and then the points P and Q split that base radius of OA into 3 equal segment lengths. The radius of the quarter circle is 12, that part is pictured, and then the points B and C also separate the arc from A to D into 3 equal arc lengths. And you can see the various little red marks indicating all of that. Now, like I said, composite area is often about what you add together, but sometimes it's about what you subtract. Another common approach here would be to say, let's actually separate out that triangle region, OPD, on the left, and then that kind of triangular wedge-ish region, PBA, on the right. And if we can find those two areas, all we would have to do is subtract that from the total area of the quarter circle, and then whatever's left over is our blue shaded region. And while that's definitely true, it is unfortunately not a great way to approach this particular problem. Because that wedge-shaped region, PBA on the right, that is not an easy region to find the area of all by itself. It looks like it's a regular old circle wedge, some portion of a circle, but remember, the center of this quarter circle is O, and AB is an arc length along that particular circle. AB is not going to be a portion of a circle centered at P, so there's not going to be a great way to find the area of that particular region all on its own. To say nothing of the fact that finding the angle at P is also pretty difficult without some trigonometry. Now, I'm going to suggest we want to be clever in a different way on this problem. I do want to find a certain area and subtract, but the area I want to find is actually going to be this entire pink shaded region from O to P to B to D. The reason I want this pink shaded region is if I can just subtract away that triangle OPD, what's left over is the blue shaded region I was interested in. Now, you might reasonably be thinking, how is this any easier than what we were looking at before? We already said it was hard to find that wedge-shaped region PBA, so this doesn't really seem to make things any better. The problem was not that triangle OPD. Totally true. That's not how we're going to find the pink region. Instead, we're going to think of the pink region as an actual triangular wedge from O to B to D, and then this triangle OPB. If we can find these two regions and then add them together and subtract away that triangle OPD, then what's left over is the region we needed, our original blue shaded region that we're interested in. Transforming the shaded region from a sum of areas that are quite difficult to find to a difference of areas that are actually easy to find is exactly the sort of idea that requires clever visualization and rewards genuine understanding, not merely memorized formulas. That's one of the reasons I'm so excited about today's sponsor, Brilliant.org. Not only does Brilliant build fantastic lessons that help you move beyond the formulas, their platform personalizes the learning to you. For example, I'm doing something like this right now with my own students as we study quadratics. Brilliant's interactive problem set on expanding and factoring quadratic expressions communicates the meaning behind processes like completing the square. I can't tell you how satisfying it is to see students have that aha moment when they realize that they're actually completing a square when we talk about completing the square. To learn for free on Brilliant for a full 30 days, go to brilliant.org/polymathematic. You can also scan the QR code that's on screen right now, or you can go to the link in the description. Brilliant has helpfully given my viewers 20% off an annual premium subscription in addition to the free 30-day trial. That premium subscription gives you unlimited daily access to everything on Brilliant. So I appreciate it. Thank you again to Brilliant.org for sponsoring today's video. All right, so let's get down to it. We can say that this distance OP is 4, and that's going to give us the base of triangle OPB. B. Because these arcs are all equal, that means that the angles at O also have to all be equal, and so we're dividing that 90-degree angle into 3 parts, or 3 30-degree angles. Which means as we drop the altitude from B back down to the radius OA, what we're looking at is a 30, 60, 90 right triangle. The hypotenuse of this right triangle has to match the radius of the quarter circle, and therefore the short side, that is across from this 30-degree angle, must be 6. That short side, of course, is also the same as the height for our triangle OPB. So for triangle OPB, we know that we're looking at a base of 4, a height of 6, and the area formula, of course, is base times height divided by 2. So 4 times 6 makes 24, divided by 2 makes 12. For the rest of this sector over here, OBD, we're looking at an area that is 1/6 of what would be the full circle area, pi times 12 squared. The reason I know it's a sixth is that this angle here was 30 degrees, but again, they added up to 90, so this other angle must have been 60. And 60 degrees out of 360 degrees means we're looking at a sixth of the total circle. 12 squared is 144 times pi makes 144 pi, and then times the 1/6 gives us back 24 pi. So if you're keeping track, we have 2 of the 3 pieces we need. The only other thing we need would be that area of triangle OPD that we wanted to subtract away. You'll notice for that particular triangle, which I'm going to try and do in white here, we actually already know the base is 4. That was the same as the base of OPB. And for that matter, we already know the height because it's just the same as the radius of the quarter circle. So that makes the area of OPD, the base of 4 times a height of 12 divided by 2 makes 24. And we're now ready to put all the pieces together. The area of OPB, which we figured out was 12, plus the area of this sector, OBD, which we figured out was 24 pi, minus the area OPD, which we figured out was 24, gives us a total area of 24 pi plus 12 minus 24, or when we simplify just a little bit more, 24 pi minus 12. And so there you have it. The blue shaded region we were interested in from the beginning does have an area that we can calculate as 24 pi minus 12, no trigonometry or polar coordinates required. That is the additional challenge that I'm going to leave to you as a viewer. Anytime I do these shaded region questions, people love to say, oh, just integrate in polar, which you totally can. And I'm eager to see you do it for me in the comments. Perhaps an easier thing to do for the less calculus-minded among you, knowing the blue shaded region area now, who can give me the area of the weird, almost circular wedge-shaped piece PBA. Not the most complicated calculation in the world, but a good little follow-up that I want to see from you. Thank you again to Brilliant.org for sponsoring today's video. Please check out Brilliant.org/polymathematic. If you like videos like this, the best thing you can do is support the sponsor, click on their link, sign up for an annual premium membership, 20% off. It's a great deal. Like, subscribe, do all that stuff, and otherwise I will see y'all next time.